Hi everyone, we're going to use the graph and find the midpoint of AB and call it G, and use the median CD to find the coordinates of the centroid G, find the coordinates of E, the midpoint of AC, and verify the distances. Basically our current concurrency of medians of a triangle. So we're verifying this formula here. So we'll get started. The first thing we want to do is find the midpoint of D, or the midpoint of AB. So here's your midpoint formula, and you just take these 2 points, and we're going to call it D. Midpoint of AB, so we'll do that first. So that's just going to be 2 plus 10 divided by 2, and 3 plus 9 divided by 2. Both of those are 12 divided by 2, so that's going to be 6, 6. So the midpoint here is 6, 6, right about there. And we're calling this D. So I'll put a D in front, that coordinate. Now, we're going to find the median CD. So basically, they said use this to find the median. I'm going to show you a different way. You can kind of look and see where it's at. But I'm going to use the midpoint formula again, but not really the midpoint. I'm going to use the average. All you have to do is to get the centroid G is to take all your vertices and take the average. So I can say that the centroid G coordinate's going to be, you add your x's and divide by 2, and you add your y's. And not by 2, but by 3, because we're taking the averages. Now that's going to give you 18 divided by 3 and 9 divided by 3. That gives you 6, 3. So 6, 3 is right about there. So that's your G. Now next thing we want to do is find the midpoint of this line, A to C. So we're going to use our midpoint formula again. So the midpoint of AC, and add your x's, divide by 2, and add your y's, and divide by 2. And that's going to give you 8 divided by 2 and 0 divided by 2, which equals 4, 0. So there's that, and we're calling that E. So the next problem, we're going to have to look at this part. This is the part we have to verify. We have to verify that B G is 2/3 of BE. So we have to find two distances, BG, and we're going to have to find BE. So I need to know G and E. So G is this, and this one's called E. And this one's G. So 6340. So this one's 63, and E is going to be 4, 0. Okay, got that down. Now, so let's find the distance first. 6, 3 is right here. Of BG. So this is your G. And that's going to be 6, 3. And we use our distance formula. So the distance of BG. So that's going to equal 10 minus 6 squared plus 9 minus 3 squared. Now that equals 4 squared plus 6 squared, which equals 16 plus 36, and that equals the square root of 52, and that can be reduced by, we can call this 4 times 17. So this equals 2 square root of 17. Now let's do the distance of BE. So E was right here. And there's your point. So I'll write it here, 4, 0. So we're using these two coordinates for BE. So we're going to do 10 minus 4 squared plus 9 minus 0 squared. And that gives us 6 squared plus 9 squared, which equals the square root of 36 plus 81. And 36 plus 81 is 117. And let's see if we can break that down. We can break this down by 9 times 13, which is 3 square root of 13. And this one I did wrong. This one should have been 4 times 13, which is 2 square root of 13. Why do I keep doing that? Okay, so 13. All right. So now we have to verify that BG, so where's BG? BG is 2, I'm looking at this, 2 square root of 13 equals 2/3 of 3 square root of 13. Now what happens is the 3's cancel, so you get 2 square root of 13 equals 2 square root of 13, and that works out right. And so we verified it. Thank you. Have a nice day. Bye-bye.